Alright, here we're given a line segment and we're given an ordered pair, and we want to find, okay, we want to break it apart into 3, 2, as far as finding point P. Point P, the ratio is 3 to 2. So remember with the ratios, to convert that to a fraction, as far as like what part of the line is represented, okay, there's 5 parts total. Okay, so 3/5, so P would be 3/5 away from N. And then P would be 2/5 away from N. So we can pick any 2 points as long as we use the right fraction here to come up with the new point that we're looking at. For this one, let's go ahead and just use 4/2. Alright, so for 4/2, we're going to do our change in x. And so what we'll do is we'll do, of course, remember it's x2 minus x1. Okay, so this will be x1 and y1. So this would be x2 and y2. So we'll use -3 minus, okay, 4. Okay, so we're going to end up with -7 as our change in x. Okay, then I'm going to do the same thing for the y. Go ahead and do the change in y. Change in y would be -3 minus 2, so we end up with -5. And then we're going to take both those and multiply it times 2/5. Okay, and so when we do this, nothing's going to cancel out. So we end up with, I'm going to go ahead and convert that to a decimal. So we end up with -14 divided by 5 should be -2.8. And then for this one, 5 does cancel out, so we end up with -2. Okay, then we're going to combine that with this one. So what we would do to figure out where point P is go 4 minus 2.8 and then 2 minus 2. Okay, so when we do that, we're going to end up, if we subtract 4 minus 2.8, we end up with 1.2, and that would be 0. So point P is 0 in the y, and then we went over 1.2, so point P should be somewhere in there. So that would be point P. Now again, we could use the other one, which, just so that you've seen it, I'll go ahead and do it. Our changes will end up just changing signs, but let's go ahead and go through the process with this. So now we're going to start with M. So we'll call that x1, that y1, x2, y2. Alright, so let's look at our change in x. Okay, so it's going to be 4 minus -3, which in this case would give us +7. You'll notice that the change is the same, just a positive instead of negative. Let's do the same thing for y. So that we'll take 2 minus -3, excuse me, and so we end up with 5 here. So they should have the same change, just different signs. Now, since we're coming up from here, and we know that this right here, from what we were told, represents 3/5, we'll use 3/5 to multiply this and this. So again, here the 5 will cancel out here, so we're left with 3 for that. Here the 5 won't cancel out, so I'm going to go ahead and, again, that was our answer for the last, which we should come up with again. So we end up with 21 over 5. So we end up with 4.2. So now we'll add 4.2 to -3. Alright, so we'll have -3 plus 4.2 and -3 plus 3. Now, because we're adding it to the x and the y values here. Alright, and so then when we combine this, we get 1.2 and 0. Again, when you're doing the practice problems, you don't have to do it twice. I just want to show that if you use the correct ratio, it doesn't matter. And be careful with your signs. It doesn't matter which one you use. You should end up with the same answer as for your point P. Now again, so what that did, going back to the essential question, is how do we find the point on a directed line segment that partitions the segment in a given ratio? That's what we went through and did in these videos.